if you flip the page over to the backside, the new question we're going to ask ourselves is how do we apply these skills to find factors and solutions of polynomials? And that was what the overview on the other side is let's just look at the example and kind of go through the process. Now, I'm telling you, x plus 5 is a factor of the given polynomial, x cubed plus 7x squared plus 7x minus 15. Well, if I'm telling you it is a factor, that means you are going to have a remainder of 0. That was the point of the front page. It goes in there perfectly. So we're going to divide out that factor, because if I can divide it out, I'm going to take and I'm going to get away from x cubed and I'm going to go down to an x squared. So let's try that out first. First thing we want to do is we want to find a 0. So just like we did with regular old synthetic division, is we're going to take our factor, which was x plus 5, and we're going to set it equal to 0. And in that case, x equals negative 5. There's your first solution. And fundamental theorem of algebra tells us, well, my degree is 3. I should have 3 solutions. Oh, right now you have 1. Done. You only have 2 more left to find. So now what we do is we take that 0, we take that negative 5, and we're going to divide it out of the polynomial. So I'm going to set up synthetic division. I have 1, 7, 7, negative 15 as the coefficients. Leave the empty space below it, and then our remainder, which we know should be 0. So that's a good way to check our synthetic division. So when we do synthetic division, remember, you always drop down the first term, and I'm going to get a 1 down here. And then we multiply. Negative 1 times 5 is negative 5. Do whatever it says vertically. 7 minus 5 is a 2. And then I'm going to do the negative 5 times 2, which gives me negative 10. Do whatever it says vertically. 7 minus 10 is negative 3. And negative 5 times negative 3 gives me a positive 15, which does give me a remainder of 0. So I know for a fact I'm perfectly right at this point. I am for sure going to get 40% of the points, which could be passing. And you're good. We now have a quadratic. I mean, after I do synthetic division with the x cubed, the original polynomial, and I take out my factor, remember these numbers, 1, 2, negative 3, represent 1x squared plus 2x minus 3 equals 0. That is what we're dealing with now. We are working with that quadratic. So the question is, how do you factor it? Well, in this case, we want to know what multiplies to give us negative 3 and what adds to give us 2. Well, in that case, it's going to be a 3 and a negative 1. So my factors from this are x plus 3, x minus 1 equals 0. Oh, look at that. I couldn't deal with it in the x cubed form, but as soon as I took out a factor and divided it out, I now am working with a form I'm confident with, which is x squared. It's quadratics. So here's what I want you to do after we go through this, is just to make sure we understand what's going on. It's going to help us out with 7.7. Write all the factors. Well, you were given x plus 5 in the beginning. That was given to you. We earned the x plus 3 and the x minus 1 through the work we did. That's the polynomial in factored form. And we can state all of our zeros from here. If x plus 5 equals 0, then x is negative 5. We saw that in the beginning. If x plus 3 equals 0, x is negative 3. If x minus 1 equals 0, x is 1. And so I have everything I need, and I know everything about this polynomial. It has solutions of negative 5, negative 3, and 1. You are expected to be able to write these out. And we're going to go into why it's important in the next lesson. It's going to make your 7.7 a lot easier in some of the parts by going through and doing this. So this is an expectation on the homework. And that's it. That's what we're going to be dealing with for most of the problems. So let's try this one. If x minus 6 is a factor. Again, notice what's being given to you. And we're going to find out in the next page why that's important. Is I'm telling you that's a factor. Again, that means when you do synthetic division, you should get a remainder of 0. So we're going to remove that factor. So let's find the first 0. So I take x minus 6, set equal to 0, x equals 6. I have my first 0. There should be, looks like 3 of them. I have 2 more left to go. I'm going to perform synthetic division with this. So take your 0, which is 6, put it in the half box, write down your coefficients, 2, negative 13, negative 9, 90. We leave our empty space, put a remainder. I told you it is a factor, which means we should get a remainder of 0. That's our goal. So we drop down the first term, bam, 2. We do 6 times 2, and I get 12. Do whatever it says vertically. Negative 13 and a positive 12 gives me a negative 1. 6 times negative 1 gives me a negative 6. Do whatever it says vertically. Negative 9 minus 6 is negative 15. 6 times negative 15 is a negative 90, which does give me a remainder of 0. Perfect. I did my synthetic division properly. I know right now I'm shooting for at least the 40% of this problem being right. That's good. So now we write down what's left. We have 2x squared minus x minus 15 equals 0. That's the quadratic that remains. And at this point, we have to ask ourselves, can this be factored? Well, let's try it out. This one is special. This one, you're going to notice there's a few of these on the notes. There's a lot of on the homework. It was on the 7375 quiz. This one's a good old AC method. We are going to have to take A times C. 2 times negative 15 gives me negative 30. I want numbers that multiply to give me negative 30, but when I add them, it gives me the negative 1 in the middle. Well, what are those numbers? Multiplies to negative 30, adds to negative 1. I'm thinking it's negative 6, positive 5. So we're going to split this negative 1x into negative 6x plus 5x. And we're going to keep the 2x squared out front, and we're going to keep the negative 15 at the end. We just split it into 4 terms, which means we have the ability to factor by grouping. So when I group the first 2 together, we'll change colors for this. The GCF is a 2x. And if I take that out, I'm left with x minus 3. If I look at the next 2 grouped together, their GCF is a positive 5. And I'm left with an x minus 3. So to finish the factoring, they have the x minus 3 in common. I can factor that out, bam, bam, and I'm left with the 2x plus 5. And there are the factors. We factor the quadratic, and that was a good old AC method. Again, for some reason, we're going to see this a lot. Maybe it plays an important role in chapter 7. Who knows? But that's just from the quadratic. Let's write all of the factors that we had. Well, the first one was x minus 6. Through the AC method, we found 2x plus 5 and x minus 3. So those are the factors of that polynomial. If I want to state the solutions, set each one equal to 0. X minus 6 equals 0, x equals 6, which is what we said back up in the beginning. I'll do this one. X minus 3 equals 0, x equals 3. If you set 2x plus 5 equal to 0, your first step would be to subtract 5, and then you would divide by 2. so I get -5 halves. I have 3 answers, and my degree was 3, which means there's a very good chance I'm right. And I say that on purpose. There's just a very good chance. Doesn't mean you are. It just means there's a good chance. Question is, how do you know if you're right with these? And that's, again, where we're going to pull up our calculator. Now, on this calculator, you see I'm on the screen. I'm going to go to my y equals. There's nothing in there. And I'm going to type in the polynomial that we just were given. And that was the 2x to the third power minus 13x squared minus 9x plus 90. Now that was the original polynomial. I'm going to hit graph, and we'll see what happens. Oh, we have weird looking graph. We can't quite see the maximums and minimums, but we do see our x-intercepts here. We do see where they cross the x-axis. Now what we want to do is we want to know, are our answers right? Did we do the factoring properly? We've learned before you can go to second graph and look at your table. And notice at 3, you have a y value of 0. That was one of our answers. And even at 6, we have a y value of 0. That was one of our answers. The only one you can't see is that -5 halves. And so here's something I want you to do with your calculators. This is going to be important for the future. We're going to do it now. You have to be able to go back and forth. I'm going to hit second, the blue button, and I'm going to hit window, which now your screen should say table setup. So if you look on your calculator, table set is in blue, so second window. And this tells me, just different settings in my table. Where am I going to start my table? Right now, my table starts at 0. I can change it to a negative if I wanted to. What's the delta table? What's the increments in this table? I'm going by ones. And here's the parts that are interesting. Independent and dependent. Back when you first learned variables, you learn that x is the independent variable and y is the dependent variable. And what that means is y values always depend on what x you plugged in. Well, notice they both say auto. I'm going to just change your independent to ask. Auto means it'll generate the table for you automatically. Makes sense. But what does it mean if I change independent to ask? Well, now if I hit second table, my table, it's asking me what x values I want to plug in. So let's try that 6. We got that as 0. Hit enter. It worked. I have a y value of 0. That means that one's right. Type in 3. Hit enter. I get a y value of 0. That means that one's right. Type in -5 halves. So -5 divided by 2. Hit enter. And now I can see that all 3 of my answers are correct. And so that is how you can use your calculator to check are your final x values right. And so that is the second page of the notes. And you're going to find out things are very, very, very similar. The overview is really, it's the same idea. Is if I'm given a factor, and notice on this page, we are dealing only with this part of the chart. We are being given a factor. I perform synthetic division, and if it's factorable, I factor it. The next page, we're going to look at what happens when you're given a 0.